keeping you waiting. And my name, hello everyone. I'm really appreciate to have such tech talk in front of such a great number of WebRTC geeks in Korea. And my name is Kensaku Komatsu. I'm working at NTT Communications in Silicon Valley offices. And today I would talk about the kinds of related topics of the previous session talked by the chat. It's AI collaboration with WebRTC. And so today I will talk about some practical use cases for such media processing binded to the AI processing with serverless architecture. I will talk from now. Yeah, and I think Sonia already explained about it, but I'm a technical manager of ECL Skyway. That is a WebRTC platform provided by our companies. And I also not doing the web application, but just in a company. And today I have talked, as I talked in the title slide, I want to talk kinds of practical study of serverless architecture for media processing using WebRTC. And this is a kind of how to realize AI and WebRTC binding. And today I will talk about three topics shown below. One is current business in WebRTC, especially in Japan market. And next I will talk about the WebRTC gateway topic. And after that I will talk about media processing with serverless architecture. So let's get started with the current businesses. And as I talked, we are now providing an ECL, that stands for Enterprise Cloud Skyway, especially for the in Japan market from 2013. And first 4 years, we provided trial services for our developers or early adopter. But last year, last September, we provide these services as a production basis. And so that recent 1 year, a lot of enterprise customers is now using our platform for their businesses. And so, for example, thousands of application is now using our platform for their free basis, and hundreds of applications is now using in the production basis. And so that it means that current WebRTC business is now expanding, and I think that actually current stage is kind of early adopter stages, but now moving to the early majority stages. And so that I'm now really expecting that business and such a technical use case will also expanding for the WebRTC. And this is the current service model of our Skyway. We are now providing P2P connectivity. Of course, we are providing connectivity between the such mobile or desktop devices for each customers. And we also are providing such a signaling platform and service platform as well. And that means that we are now only focused on the client side for the WebRTC. And I would talk to you that the current use cases are what our customers are doing with our platform. This is the very major cases for the using WebRTC in my country, that means Japan. That is an online English education company called RealJob. Previously, this company, RealJob, provides such a remote English education services between student in Japan and the teacher in, for example, Philippines. And they use Skype to communicate with the student and teachers. And as a channel, they provide some educational content. And that means that March channel they used for the such education content and the video streaming, video communications. But there are a lot of programs to use such different channel. One problem is that student and teacher has to exchange their Skype ID. That is sometimes makes very big difficulties for the students. And other kind of issues, such education provider has to support how to use the Skype or something else. And if the Skype changes some specs for the usability or user interface or something else, they has to support such a changes. That's a really big problem. And so that this company is now moving to the Skype, from Skype to our services Skyway to include such video communication features inside their application, and that is shown in the right bottom side. And you can see that in the same application, such educational content and video communication feature is provided so that they don't need exchange such as ID, such as Skype or telephone numbers. And also, it is really comfortable and easy to use for the customers, that means students and teachers. And it really decreases the supporting cost and something else. And of course, usability will increase. And that way, our customer is now using. And those kinds of use cases also apply not only such education use cases. For example, online healthcare use cases, companies now using our platform, and field engineer support use cases, people is now using WebRTC. And that means that I'd like to say is that WebRTC is not only for video conferences. Yeah. For such generic use cases, but it want to use such video communications. They are now using our platform. And that is a key point. But current requirement from our customers is now expanding. As I said, currently we are not providing a client-side SDK only. That means that people can use such a video communication feature within our platform. But such voices, for example, service recording voices or video, and voice recognition, translation. This is explained previous session by chat, and video, and emotion, and raw exchange live streaming. We are aware of that means that video mixing or something else. Yeah, those kinds of features is now beginning to require waste from our customers. So the question is that, and those kinds of media processing for AI and IoT use cases, yeah, we are now having that. And so the question is that how do we support these needs from our customers? One way to address those kind of requirement is that to use local processing explained by chat. That is really fantastic. But sometimes it is kind of hard because it requires, those kinds of way requires client-side processing that will lead to the increasing of the battery usages and, how to say, dependency for each client's devices. Yeah, that is really hard to support. So that I will explain how to address such things using WebRTC. And so that to reduce such a client power, I think that one of the fantastic way to do such processing is that to use server-side processing using WebRTC gateway. And in this slide, I will explain about what is WebRTC gateway in a nutshell. WebRTC gateway is a kind of protocol gateway of WebRTC, so that, for example, video and audio stream from the client were transferred to the server side by using WebRTC protocol, and this WebRTC gateway transfer works as a protocol gateway. Then raw video and audio stream data will be obtained at the server side with the RTC protocol. And after that, it is really easy to process such video and audio data, streaming data by the processing engine, such as D3Man or something else. And we are starting to provide WebRTC gateway for our Skyway. And with our gateway, people can control with REST API. It is already easy to connect from Skyway client. And we also support Linux and Windows. So that most of the platform you can use the server-side power to process such media streaming data. And we are providing gateway in the GitHub. And here I will talk about the use case for such a server-side processing. One is very simple, that it's a server-side recording. As I said, such a video audio data will be transferred to the WebRTC gateway, and it is obtained as a raw data of the media streaming as RTP. And so that combined to the such a decoder and encoder if it needed, and then both the cloud storage such as AWS or cloud storage, people can easily store such files or bigger data into the cloud using WebRTC. That is really simple use cases, but it's really powerful. And the second use case is voice recognition. Yeah, it is explained by the chat in the previous sessions. And the differences from the voice recognition and such recording use case is not so different. Yeah, just transfer to such RTP data to the decoder. And for example, for the voice use cases, PCM audio data will be obtained from the decoder, and then transferring such data to the voice recognition engine, such as Google Speech API or some kinds of third-party platform APIs. And such a recognition result, when we receive such a recognition result, simply post to the database or something else, people can easily use such a AI processed data in the application. That's very powerful. And as I talked with the WebRTC gateway, it is very powerful for processing such media data, including AI and IoT processing. But how do we manage the service for such a use case scenario? That is a very big issue. So that's the next topic I will talk about these questions. Current server-side system is already based on the microservices model, and such a media processing model also applied. Yeah, it will really fit on the media processing. And so that for the management side, building some media pipeline, binding with such each service functionality. And after that, we can obtain such agility, flexibility, and scalability of such a media processing scenario and services. And we also try to implement such a system into the cloud, but we found some issues to make to apply such a microservice model into the media processing. Yeah, and there are a lot of issues that most typical and big issue for is the scalability issue for each component. Especially such video encoding, such as VBA, VB9, or H.264. It requires a lot of computer powers, and also it depends on the some parameter of the video. For example, resolution, frame per second, how the object is moving. That really affects to the CPU power for the media processing. So that we need to support it very controversial and complex usage of such media processing. And so that we need to allocate much resources for it. That's a program. And how do I say, to allocate such resources and to test how much connections we can support in the microserver, and how do we calculate and design is a very big problem. And that is really hard. But currently, we have a really fantastic approach architecture that is called serverless architecture. That is really based on the function as a services, for example, provided by Amazon Runtime. And the generic server model, each server will wait whenever such a request or session is coming through from the client. But in the serverless architecture model, such a function it does not exist unless the request was something from the client. That is a very unique point. And so that, for example, generic web access models, client will access to the API gateway, and this API gateway will hook the event and then spawn the functions. For example, communicating with the database or something else, and make a response to the client. Then after that, such a function will be killed in each session life cycle. So that means that it's really easy to make a scalability, because if the concurrent session is coming to the system, simply this run function will be increased with a container based, so that we don't need to test how much session or something else will be processed by the servers, because session is enough to support such a processing in the serverless architecture model. And of course, they don't have long-term state issues. Almost banned the issues for the system is based on the state issues. And so that if the process is read for the match to connections, if the system has some state issues about, we will face very serious conditions. But in the server section model, such a function will be directed after the session response was obtained, and so that we don't care about such issues about for the state conditions. That's really powerful. And so that we are now applying such a meta-precision model into the serverless architecture. And here I have to say that such a generic platform services for the serverless architecture is hard to apply for the media processing because, for example, AWS Lambda does not support long-term execution of processing. Yeah, it will be killed after 90 seconds as a maximum. And you can imagine that for the media processing model, it will long live more than 90 seconds. Maybe 1 minute, maybe 1 hour, maybe 1 day, maybe 1 year. And such a media processing has to support such a long-term connectivity. And so that we build a serverless system from scratch on top of the Docker container. And if the such a WebRTC session is coming to the WebRTC gateway, that is running on the containers, and starts such other processing engine, for example, decoder, the recognition engine, or something else. In this way, we can achieve such a server-side processing with serverless architecture. And we can have a very scalable and flexible systems, services, functions within this framework. And I will demonstrate this system before these sessions that there is some connectivity issues of the HDMI with my laptop computer so that I can demonstrate our system based on serverless architecture. I'm so sorry about that. But I am here until the lunch will finish. And if you would some interested with our systems, please ask me. I will show you the demonstration. And this is really hard to explain because I have to demo it for you. But there are a lot of class who are applying such a serverless architecture to the media processing in the cloud. Yeah, plus is that with such a serverless architecture, we can get flexibility and scalability and agility. Yeah. And we do not need to care about the execution pattern, then should be function. And it is very easy to release components. And in the serverless architecture scenarios, each function and process is executed for each session. That means it's really isolated for each session. And so that it's really good, for example, security perspective. Yeah, if there is a noisy neighbor, but it will not affect for the other sessions where it can. And so cons is that for the microservices and the serverless architecture, we have to care about a lot of server functions in the use case scenarios, so that we need to have a consolidated monitoring system for it. Without that, if any troubles, you have to log into each component and check log or something else. It's really hard. So that such a consolidated system is really important for that. And then, second concept is control each components while setting orchestration into code. That means that, as I said, such a media processing scenario component will be executed at the beginning of the session, and the second component will execute individually. So that means, how to say, I'd like to say, to support user scenario, all components has to be executed. That is the problem. Yeah, especially in the beginning of time. One component is now executed, but one component is not still set up in processes. That means that there is kinds of synchronizing issues to support such a scenario. And for example, such a video cases, there is a key frame inside the streaming. And so that for the media processing, we have to start from the key frame. But such a component will start, when to start, we don't know. And so that handling such a key frame is kind of a hard issue, so that we need to be careful. Yeah, and the several time issue is will happen, as I explained, for example, such a key frame topics. And this is the summary of my presentation today. I talked about the current business in WebRTC. It's not used for batch. It is now used for batch of use cases, and so that the current email processing is required for our customers. And the next topic, I talked about RTC gateway. It is an enabler for the media processing for the server side. It's very fantastic. And last topic.
박수 한번 더 부탁드립니다. 진짜 와주셔가지고요. 감사합니다. Thank you.